So we've seen that CNNs can be very computationally intensive, and there is a trick for making that run much faster, and that's called max pooling. So let's explore what max pooling is in the context of CNNs. The concept is really simple here. So the idea is just to reduce an image down by looking at some group of pixels in it and choosing the highest value within that group. So let's imagine this represents some sort of image data, and the pixels are represented by the numbers 0 through 10. Maybe that's like a grayscale scale from 0 to 10 or something like that. All you need to do is take the maximum value that you see in a given block. So for example, if we had a 2x2 kernel for max pooling, we'd start by looking at this 2x2 piece of our image here. And what's the largest value that we see in that piece of the image? It's 6. So we would reduce down the 4 pixels in this 2x2 block just to the value 6, and that's what ends up in our reduced image here over here. We would then move on to the next 2x2 block, pick the highest value, in this case it's 8, and that goes into our reduced image here. So on and so forth. Down here the biggest value in this block is 3, and over here the largest value in that block is 4. That's all max pooling does. Why is this important? Well, you can see that the number of pixels we have to deal with increases with the square of the dimensions of the image. So by reducing this 4x4 image down to a 2x2 image, we've gone from having 16 values to process to just 4. And we've actually captured most of the important information in that image still. So this can really speed things up and make your CNNs converge more quickly. And this means you can actually do more intensive processing on the data by basically throwing away some of the data, but doing it in a somewhat intelligent way. Now you would think that this could be a bad thing, but remember, as we get higher and higher up in the layers of a neural network, we're looking for higher level features as well. So all that extra detail that's in the finer resolution of your image probably isn't really that useful if you're just looking for like the shape of a horse head or something like that. You know, each individual hair on the horse doesn't matter when you're trying to identify these larger patterns. So you'll often find that even though you're throwing away some image resolution by doing max pooling, it actually can improve your results in some situations, and often it doesn't really have any detrimental effect. But the real benefit is that it really speeds things up considerably. And in Keras, it's very easy to add a max pooling layer. It's just like any other layer. You just say max pooling 2D with the kernel size you want, and it just does it. So let's actually dive in and try to improve our image classifier by using max pooling and see if we can make it run faster without giving up any accuracy in the process.